About the Satish Dhawan Space Centre. So what was here and how did we land up here?
Actually, Vikram Sarabhai and his team are scouting the entire India, even the east coast, sometimes Kadalur, Kanyakumari, like that they were going up to Odisha. So we require for a better launching capability. We should go as near to the equator as possible. That's also the better.
This is the closest to equator.
Closer to equator within this area. After the Chandrayaan 2, we had an orbiter.
Correct.
And we are not able to do a soft landing the way we wanted it. We worked on all different systems. Some of the systems, sensor system of how do we do. Actually, Chandrayaan 3 landing system, last some 6 to 24 experiments were done at SHAR before. That is, we put up a simulating a moon surface and from 100 meters down, how do we land for different assets.
So we made a moon-like surface here?
At SHAR. And we tested the propulsion system.
What weather is not right for the launch and how does it affect us?
When the weather is has a lot of charged particles. Because of the solid motor and this one, and the flumes comes into almost 10 to 20 meters, when the launch vehicle goes in that corridor, these ionized charged particles likely to get shorted through the flume to the ground. Then vehicle will get destroyed. So this is an important aspect.
Welcome, sir. Welcome to JK Super Podcast. It is an absolute honor to host you. Sir, to begin this podcast, we would like to know more about you, sir. From where did you start? What was your background, your childhood and everything? Please, sir.
Yeah, obviously my name is, everybody knows, A.Rajarajan.
Yes, sir.
I was born in Chennai.
Okay.
Then my father, at the age of 2, he moved to Trivandrum. He was in the materials area. So actually he joined there in Trivandrum. So from 1966 onwards, we are in Trivandrum. So my entire childhood and studies, everything was in Trivandrum. Studied in a government school, passed out in 10th standard, joined a pre-degree. At that time, it's not a plus 2 in school, it's a pre-degree in the college. Then straight away we joined the Trivandrum Engineering College. There's nothing to worry because people told that is the college. So yeah, I just applied one college and got through. I joined mechanical engineering and I passed out in 1986. Straight away during the college time itself, there was some interviews. So one of them was Vikram Sarabhai Space Centre of ISRO. Attended the interview, got the job. There was a small dilemma whether to join here or NALCO. I got some job offer in NALCO and so on. I was trying to push it to go out of Kerala so that let us see India. But as you know, destiny holds. So I selected the date of January 1st of 1987 to join ISRO. In Vikram Sarabhai, I joined. Me and I have a younger sister. We were all go together in Trivandrum.
Okay.
So Trivandrum is a very nice place. Everything was going well. So academics was just, it went through. Studied well. So it happened like that. There's no pressure of whether we are achieving. We never know whether, got an engineering.
Sir, what I would like to know from you is that give me some context and some history about the Satish Dhawan Space Centre, sir. From where did it all start? What happened? What was happening here? What was before this? What was here? And how did we land up here? All of that, sir, if you can just give me a little context and history about this place.
Before that, I tried to elaborate.
When
Vikram Sarabhai, from the history, because I joined in 1987, so I read from the archives that is available and all those things. And it's a well chronicled stories. From 1963 onwards, when Niki Apache rockets was all assembled and we tried to put a launch from Tumba Equatorial Station. That's why Vikram Sarabhai Station came in Trivandrum in Tumba. Because the magnetic equator is passing through that. So we are trying to do the upper atmosphere studies. So when such a things was going on, so India is one country which was very much looking at the application side of the space technology, how to utilize for the beneficial of the society, human society. So in that aspect, when we looked at some remote sensing has to be done, then we have to look at the communication capability. So we require for a better launching capability. So it's always better to launch from the east side of the country because we have to take care of the Earth's rotation. So that velocity also can be added. So looking at all aspects, actually Vikram Sarabhai and his team and all those people were scouting the entire India. Even the east coast, sometimes Kadalur, Kanyakumari, like that they were going up to Odisha. they hit upon this Satish Dhawan Island. And it was a nature's gift. It was scarcely inhabited. There are some people inhabited.
But not much.
Not much. For the area, almost 45 to 50 kilometers by 14 kilometers. Maximum width is 14 kilometers. A spindle island with a tail, with a tail in the southernmost side. So and from here it is an ideal. We have very good azimuth from starting from plus 30 to minus 145 to 150 degree. We have wide range where we can launch and there is no immediate danger falling onto any nearby places.
Correct.
So that freedom, along with any mishap happens, the southern portion works like a buffer land. Nobody is available, so nothing will happen. The safety aspects also taken care.
Correct.
And such an island alone, so naturally guarded.
Only one island in India.
Yeah,
Like
there
this.
are two islands, but this size. And we should go as near to the equator as possible. That's also the better.
This is the closest to equator.
Closest to equator within this area. So such a place of around 45,000 acres we hit upon this. So we set up government, all the other procedures followed. And we had the first launch in 1969, I think.
Were you there, sir? No, you were not there. You joined in 1987.
I joined ISRO in 1986 and moved here in 2019.
2019 you came here?
Here as the director of the But I had a lot of interaction throughout my career. I'll be used to come here for the
So 1969 we did the first launch. Successful launch?
It is a sounding rocket. It's a simple launch.
Okay, simple launch. Okay.
Then came lot of development. The infrastructure is put. As you know, our launch vehicle has a boosters made out of solid motors. So the designs were done at Vikram Sarabhai Space Centre. But the realization of the propellant, the solid propellant was done here. And it's not easy to transport a big solid motor through road and all. But it became a cumbersome effort. You have to put a lot of safety aspect into it. So solid motor processing unit was put in for the PSLV. So that was really, it's called SPROB.
Correct.
Solid propellant booster motor plant. So that we started with a capability to make a 2.8 meter dia segments where we will put 25-ton propellant.
So just to put it in context, sir, in 1969 we do the first launch. Right after that, what do we construct and how does the construction begin?
1969 we just showed whether we just worked out a methodology of sounding rocket launch.
Okay.
So that is enabled. So we have established a launch system. Now you have to go for a full-fledged range system.
Correct.
It's like if you want an airport, it's not only the airstrip alone is not sufficient.
Absolutely.
You require all the communication system, determining system, whether weather is okay, whether you can launch through it during a weather, the tracking system, the telemetry, telecommand. So many range system has to be put in place. So this is called range. Rather than we call it Satish Dhawan Space Centre, before that it was called as range.
Range, Sriharikota range.
It's range.
Yeah.
SHAR is a misnomer. It's not a Sriharikota range we call.
Okay.
That range has a launch pedestal.
A launch pedestal is the place from where we launch.
Okay. And you should have a very good weather system to look at whether it's, because weather is an important constituent to decide whether we can launch.
Sir, give me an example with what weather is not right for the launch and how does it affect us?
Since we are gone like that, when the weather is has a lot of charged particles. The weather is not only dry weather on this one.
Okay.
If because of the solid motor and this one, and the plumes comes to almost 10 to 20 meters in its tail when it's exhaust. If there is a lot of charged particles are in place, when the launch vehicle goes in that corridor, these ionized charged particles likely to get shorted through the plume to the ground. Then vehicle will get destroyed. So this is an important aspect. Second aspect is, that's one. Second aspect is the wind. When I say wind, it encompasses not only this weather or rain, upper atmosphere wind speeds.
Correct.
This wind speed will enable you to control because the angle of, we call it as angle of attack. So wind is flowing and the vehicle is supposed to in a designated path. If velocity of the wind is beyond a limit and in separate altitude, it will unnecessarily increase more load on the control system because it will make the vehicle move.
Correct.
And it will try to control and try to come to the desired path.
Huh.
That means there is a lot of load on the system.
Huh.
So we have to look at it, what is the vehicle designed for. You should not go beyond that capability of the vehicle.
Correct.
So this also plays a part, and we measure the wind speeds in various altitudes. So we have some wind profiler. We put a balloon, see the wind velocity in which direction it's going at different altitudes.
You have balloons for all the altitudes?
Yeah, it will go on. It's a hydrogen balloon. It will go on, get lifted up to 40 kilometers.
Okay.
So throughout the 40 kilometer altitudes, we will measure the wind speeds pattern in different places, in different times. 1 hour before launch, 1 hour at the time of launch.
Okay.
Just to have, because launch can be shifted even 20 minutes, 30 minutes also, because preparations will be going on.
Correct.
So that way, we have a set of weather predictions and we see actual weather.
Okay.
So that should be within some tolerance and bandwidth.
Yeah, okay.
Now we have a wind profile which go up to 20 kilometers. We will accurately predict what is the wind velocity condition throughout this height.
Correct.
Like shear wind. So many winds are there. What you see wind is not the one which is there in the term.
And is it much more?
Yeah, it will be in a much different direction also.
Okay.
And it will be a very high speed also.
Okay, it's way more high than what we see here.
Obviously. Yeah.
Okay.
Because once you know that, with that we manage the day of launch wind biasing systems. That's called biased systems. So this is a well-known technique nowadays.
Correct.
In earlier days it is different. So we do this. So these are all important. Then the timing. We have to synchronize the launch vehicle and the timing at the ground. And we should be able to track the launch vehicle with our radar system. And anything goes beyond its path, we should terminate the vehicle.
Okay.
So for that there is a telecommand system. So that also, this all has to work without any compromise.
So sir, if it goes a little beyond its path,
beyond a designated deviated path, because it may fall on somebody's land.
I understand, yes.
That's the problem. Then we have to terminate the vehicle.
Sir, can you please tell me how much is that range that you guys allow?
Yeah, it depends upon the capability of the vehicle.
Okay.
And once it's flying, it can go beyond we call it as instantaneous impact point. Instantaneous impact point of a vehicle in whichever way. It is not a straight path. It goes in some designated path. So at any instant, something happens, tangentially it will fall on to some vehicle. So that we make sure that it doesn't only falls on international zone. So we get the clearance from it's called NOTAM.
Okay.
That is the air intimations.
Okay.
For all the flights that's going on, not to come into this path. Where sometimes even the sea navigation in the sea, they all will be identified that don't come into this path. We are going to have a vehicle. It is only to make sure that any mishap happens, nobody gets hurt or got anything. And this is a standard way of doing in all the launch pads.
Okay.
So this system also is put in place.
And if it is at all out from the range of that range,
we have bandwidth.
You will immediately terminate it.
It will be terminated.
Sir, there is a layman question that I have. I'm sorry to ask you that. How do you guys terminate that? Is there some?
Yeah, that's a destructive system in the vehicle.
Some sort of explosive?
Yes, little bit of explosives will be there. So we will cut open the stages so that it no more functions as a vehicle. It will get destroyed and drop immediately.
Okay.
This is a standard system. It is as a responsible nation, we have to put all these things in place because we should not disturb the others.
Absolutely. So you've told me so far that you check the wind speeds, the range is there. Then what happens, sir?
See, this is a ranging system. So the networking, the most important is the network. When the PSLE or GSLE or LUM3 vehicle or launch pad, for minimum 3 to 3.5 kilometers, nobody will be there. It is all taken out.
From the launch pad to 3 to 3.5, not a single person.
Not single person. And we usually sit around 5 to 7 kilometers away. And there will be some. This is around 2 to 3 kilometers is the safe zone. Anything happens, up to 3 kilometers is a danger zone. So beyond that, all the battle-ready people will be there to take care of something. Then people who take decision will be there at 5 kilometers. We call it a 0 point.
Okay.
That is, beyond that you don't go.
Okay.
You go towards the launch pad. So now, how do you communicate with the launch vehicle's computer system? So that should be a networking system. The hardwired networking system as well as telemetry. Both are available. So we make sure that 2 to 3 backups are there. Not only primary path, So all the preparation of the vehicle and the before launch vehicle goes into the automatic launch sequence system that the onboard computer takes over. We check all the parameters. We look and we'll load the fuels, liquid fuels. In the last minute, within 5 to 6 hours, we'll load the liquid, air storable liquid fuels.
Last 5 to 6 hours you load the fuel.
7-8 hours. Yeah. Cryogenic fuels will be loaded because keeping an liquid oxygen, liquid hydrogen in that kind of atmosphere for a long time is very difficult.
Risky.
So it is the last, as the last activity only that will be loaded.
Okay.
But it also requires 2 to 3 hours or 4 hours.
Correct.
So we load the fuels. Then before that we use the storable fuels, some 12 hours behind before. That's for the liquid stages. So all this we will covered. Solid motors are ready. The ignition systems all are checked and kept. Then we go on check the parameters. In the meantime, the range system will do its own checks. So whether we can give the clearance. So one day before the launch sequence, we launch authorization board where the center of director of this center will happen to be the chairman.
Correct.
Chairman, Secretary DOS usually keeps that person. So we check all whether it is ready. It is like akin to say that whether the aeroplane is now ready to go for takeoff.
Correct.
So it has to have the fuel, the passengers to be loaded, security systems are in place, locked, the communication systems are in place.
Everything
like
will be
the pilot is same similar something akin to that. But the same thing, it is just in a precision method because vehicle is an autonomous mode and it is going at a very high speed. It's going to accelerate like anything against the gravity of the earth. And the payload, satellite is assembled. The fuel charging of the satellite also would have been done.
Correct.
So that assembly and the health check of that spacecraft, whatever payload put in a launch vehicle, that will be continuously monitored.
Correct.
Different experts, different groups will be in different places and do. And all the data will cover important aspects. The go, no goes, decision makings, all will be given. Then last 30 minutes, the automatic launch sequence takes over.
Okay.
So it checks.
So in the last 30 minutes, you guys are not doing anything.
We are not. We are only checking all the parameters.
Okay.
See, that's why you would have seen why you are keeping cool, all those things, right? So it is not what was to be done and whatever knowledge is, we are
already done.
Now sequence starts and we look for any change. Then we look at the last minute whether any launch takes.
So when does the last weather check happens? Last weather check.
Usually it takes on the 35 minutes to 45 minutes.
For the last weather check.
Because it takes around minimum 20 minutes to check.
Okay.
That is one of the criteria.
Till 40 kilometers or till 20
Yeah, it will go to 40 kilometers. 20 kilometers is important.
Okay.
20. But we do a wind profiler 25 minutes before also.
Okay.
So that gives at the 0th time also we can do a check.
Okay.
It was interface vehicle.
Okay.
So we give the actual data. Usually this has been done for last 5 days. So the pattern will not simply change.
Okay.
So even the changes up to some permission level is okay for us.
Correct. And then you give a go ahead and the launch happens. Sir, you as a director of this place, what are your responsibilities around this place in terms of the capabilities of launching, in terms of the people living around here, the quality of life that people maintain here? All of that comes under your responsibility?
Yeah.
So what exactly is your role in this Satish Dhawan Space Centre, sir?
So, okay, as a director of the Satish Dhawan Centre, I have to take care of the techno-managerial aspects of the launch vehicles and the spacecraft systems and the ranges.
Correct.
And we also make solid motors here.
Correct.
On first stage. In addition to this, around 2,300 people are working here and their families.
Correct.
And we have some tribals, or I won't say like that.
Okay.
The people, some people who are working on a contract live nearby. Around Yanadi tribe, some 900 huts, they have been put in place. In addition to this, some around 2,000 contract people are doing all the sorts of work in helping our day-to-day work of range systems. It's not only our own department people. Along with that, there is a 2,000 odd contract people working in different aspects of it.
Correct.
You already know that this is an island,
yes,
remote. We're at least 20 kilometers away from the nearest town.
Yeah.
So, and there's only a single road connecting to us.
Correct.
And when here, we take care of not only the well-beings, we take care of, it's like, we call it as a municipality.
It's a city. It's a small city.
I won't say city, it's a town or a township, trying to put it. So around 3,000 quarters are there here.
Yeah.
Even I live here.
Yeah.
And we take care of the entire aspects of day-to-day life requirement.
Okay.
Bringing in vegetables, water, milk, and the treated water system.
Correct.
Not only here, though there are around 2,000 quarters are there in Sulurpeta, where people are housed here.
Okay.
Around 1,000 odd of people
Here also.
including. And we also have 1,000 odd CSF people here, staying here.
Okay.
So their family, out of them, around 400 of them have families here. So we have schools situated all around the places.
1,000 CSIF
Yeah.
people
This
here.
is a big island, no? Yeah.
Okay.
As you recall, when the township is well planned.
Okay.
The people who conceived this, there are doyens starting from 1969 in the island. We had decided. So first we had a smaller sheds and this one for people to live. It's not that easy. It's not that cozy also.
Okay.
But what to go by? So first hostels were put where we are staying in the Kalpana guest house and all those things. It's the one with Aryabhatta. There is a hostel was put in place. Then some sheds were put in place. The bachelor's quarters, we call it as it's all a very, if you look at it, it's a lot of bonhomie was there.
Yeah.
Today everybody is staying in individual quarters.
Yeah.
That time we have to even share. I can remember when I came here visiting my colleagues, all my peers from different places, they are also joined the same time. So you have to, there's only one bathroom, you have to share with a bucket, you have to take the water and go to the bathroom, wait and take. It's like college days, we didn't follow, because you can't expect something grander to him. We are a country under development at that time, and the rooms were shared. Actually, we are all 3 people in one room.
Okay.
When we come on tour in 80s and then in 90s. But it's taken for granted. We require one bed. We are happy chatting with the people. We get to know a lot of things from other people.
Absolutely, yeah.
Yes, that's the most important aspect.
Beautiful experience.
Yeah. So I remember those young engineers, younger days, working. When you come here, you have to work for 1 week.
Correct.
And finish and then go back.
Correct.
So those people will be those who are working here. They will be there trying to further work on this. So there's a bonhomie between people and how people work and interact.
Yeah.
We understand each other, and they also is not living. So we may be going back to our Trivandrum and sitting. The people here, I will say, we understood the psychology of this one. They are in a remote place. They look at this. So they work almost 24/7 here. So we have to give the amenities.
Correct.
Slowly the amenities, the sanctioning comes, the quarters started coming in.
Correct.
And the hostel, guest house also started improving.
Correct.
Then we have provided the canteen. So the aspect is, we know, see, like it is a big family.
Correct.
So the things will start coming. So there is a market opportunity. The trading opportunity comes, people will definitely put up shops here.
Sure.
So we put it in like any township. It's not anything. And electricity is made available. At the same time, what are the infrastructure plan, the growth vision,
Correct.
where to locate each one. As we grow, how it will go. It should not hamper with the other people's growth. So range systems will be different places. The solid motor development will be different areas. Launch pad will be positioned. Even for future 2-3 launches, how to happen. Launch pad if you want, where to keep positioning those things.
Okay.
That also we should have a vision, right?
Absolutely.
So all those things are put in place. Slowly it develops. Now what happens in the present situation is, it's a municipality, the mobility is better. So we are able to bring in all these things. People can stay wherever they like, but within the shortest distance possible.
Correct.
Because it's a range. So people have to come and
Immediately
attend to do. So we have our own schools here. We have our own. In our own role, we have teachers. We have 2 hospitals, one in island and one in the mainland.
Okay.
Because there are 2,000 people staying there.
Okay.
So those people, we got Satish Memorial Hospital there and SHAR Hospital. We have our own experts, doctors. So we are taking care of their day-to-day life and all those aspects. I will rather even put it like this: we are able to see the specialty doctors within a short time.
Okay.
Unlike big cities, there you have to really take an appointment.
Yes.
Here also you have to take an appointment because our code, they will be seeing around 30 to 40 patients per day. So, so that means you are addressed to. So, and we also bring in specialist people, doctors to take care of people's and the dependents' health.
Correct.
And we do a periodical checks, both for the prime employee and spouses or the dependent. depending upon the age limit. We do some periodical screenings
Okay.
just to be aware of the health issue.
Yes.
Second, school is there up to 12th. Then the only problem is beyond 12th you have to really go out.
Yeah, then
That's one of the issues for any township.
Correct.
It applies to any township.
You live in a city also, you have to, mostly people go out to other cities.
Won't really go out.
Yeah.
It's obvious. The third aspect is whoever comes, the food is the important aspect. So that is taken care of by the guest house services and other things. So once we make sure this, we give a bus service, mobility services to bring in people to this.
Correct.
So one aspect advantage here is people are within 10 to 15 minutes from the work spot.
Oh, yeah, okay.
That we can say.
Okay.
So, and we are available here. So, and one important aspect in Satish Dhawan Space Centre is the launch campaign when it happens, everybody is on toes. All the components has come here. So the last mile activity happens. So we can't afford to make a mistake.
Correct.
This has to go and get ready for the targeted date of launch.
Yes.
Put the spacecraft in place.
Yeah. Sir, if there is a launch about to happen, like if there is a launch coming up, how long back you have to start the preparation?
Yeah. Good question.
Yes, sir.
I will take some time to elaborate,
please,
to understand
the
scenario.
Take all the time, sir.
You know, we have a societal responsibility and we spread across throughout India at different places.
Correct.
For example, the launch vehicle is being conceived and developed by the Mother Center, Vikrant Sarabhai Space Center in Trivandrum. And there is a liquid propulsion system center and inertial system center in all are in Trivandrum. At Bangalore, we have the spacecraft center. You call it URO Satellite Space Center. Satellite Center. So that takes care of configuring a satellite, designing and configuring. Then we have a space application center at Ahmedabad, which takes care of the payload developments.
Okay.
See, we have a bus which is carrying to the space to be kept in space, which does all the orbital maneuvering, keeping positioning system, everything taken care. There will be a communication system, data transfer capability, all of it. Some payloads also from URSC. Then the Space Application Center develops many payloads within ISRO.
Correct.
Then NRSC at Hyderabad does the National Remote Sensing Centers. Then there's the Instrac for tracking the satellite and the MCF Hassan at Hassan to track the communication satellite.
Correct.
So these are all places. And there's a PRL in Ahmedabad and different Indians. Many people can have their own payloads, like Indian Institute of Astrophysics, TAFR. So many people have scientific payloads.
Correct.
That has to be positioned into the spacecraft. So that configuration is done at Bangalore. Now, all those people, then the launch vehicle when it's conceived, it has to be realized through many industries. Throughout India, almost 80% to 90% of the launch vehicle is made through industries only.
Correct.
It is all huge structure.
Absolutely.
We only do the final checking,
assembling,
like avionics, some small, some areas which all comes through industry. We do the final checking. Now I will put it in such a way that around industries of more than 1 lakh people work in the industries, make this item. Then 18,000 people in ISRO does various jobs in all these aspects of different sectors like structures, mechanisms, combustion, propulsion, whatnot, instrumentation, navigation, guidance, controls, mission algorithm, aero, all that. And in SHAR, they make once solid shells are being designed by VSSC that comes from industry, comes directly to SHAR. We have to cast the propellant. It's a very risky propellant.
Correct.
Solid motors. That has to be cast around 100 tons. Has to be cast into that motors. And the nozzles are made at VSSC and we have to see the assembly and check the systems. So the algorithm, the software, the controls, electronics, the mechanical system, whether it can take the loads, all those aspects are tested and checked. Then we do a testing here also. The meantime, the liquid stages are all, the fuels are all brought. It's all checked and kept ready. The aviation, like aviation fuel, fuels are kept. Then solid motors are being made and kept ready. The assembly group here in SHAR, they will do the solid motor and check. The range system makes they are ready. Now I'll again come back to it. So 1 lakh people in industries are making these parts, and 18,000 people of ISRO join put. At most, it will take some minimum. Once it's ready, it's some 15 to 16 months of work.
Correct.
Of this is being added.
Correct.
So 15 months of time, the amount of, I will not get into what is the actual amount. You will say some 200 crores to 300 crores of vehicles. It's being pumped in and all are made. Now spacecraft of depending upon the capability and difficulty aspect. The spacecraft cost can vary from 300 to 200 crores to 40 crores to even 600 crores. Because it's around 15 years of life we are going to give.
Correct.
In space. That is being assembled at Bangalore and Ahmedabad and all other associated agencies. PRL, scientific payload means PRL will take some lead in the SPL. So different agencies throughout India and some international, depending upon the viability and other aspects, get assembled, tested at Bangalore. That also takes minimum 2 years to 3 years, depending upon the difficulty of the satellite. Sometimes 1 year also is possible. These are all this now starts coming
Together.
Landing at SHAR when the launch came in last 100 days. Now you can understand it is so many people's of effort, time, money, and we can't afford to make a single mistake on that last 30 to 45 days.
Absolutely, yeah.
So this all gets covered. Now you can understand what this is like a military type, hierarchical type, rigid with SOPs. We will discuss, debate n number of times. But once you conclude and finalize, how do you make, how do you go proceed for each item? It has to be followed in the spirit of letter and
Correct.
Right, to the last word.
Yeah.
Then only the assembly will go smooth. And in that, any deviation comes, it will be discussed then and there and a decision will be taken. At that time, SHAR, SDSC SHAR takes the responsibility of doing this launch in time. So now we can add, what is when the value addition in the last 45 days is so high. If only one place something damaged, that alone goes out. But when it gets assembled and something happens, the entire stake, it's not only the effort of this 50,000 or 1 lakh people of an industries and 18,000 people of ISRO. The time, the clock is getting set back by another 2 years.
Correct, very true, sir.
That is most damaging than anything. So we have to, so it will be meticulous. So the rocket science is nothing but thousands of small things happening in precise time in the precise milliseconds. Small things has to happen in right. I will put it
very well,
in
sir.
my way. I will put rocket science as this.
Very well, sir. Sir, now that you've told us about how difficult it is and how important it is to put all of this thing together meticulously, we will go to the most exciting part of any space company or any space organization, and that are the missions. So let us discuss a few missions over here, sir. Like the last most talked about mission was Chandrayaan 3.
Yes.
Sir, what was happening the day it was launched? Walk us through that, sir, please.
After the Chandrayaan 2, we had an orbiter.
Correct.
And we are not able to do a soft landing the way we wanted it. We worked on all different systems. So I will take it to, so the Chandrayaan 3 was conceived where we don't have to have an orbiter.
Okay.
Because we have one of the best orbiter, Chandrayaan 2, which is giving all the images. So a lot of data are pouring in about the moon. So we are able to surface moon. So the location we have decided. So we also looked back and what the mistakes made. So even as our secretary, Dr. Somnath told, we look at it and whether we can cut down on engine. Too many engines also is playing a part.
Correct.
So all those aspects have been really looked at it. Some of the systems, sensor system of how do we took. So it is like a human being.
Correct.
All those aspects has been worked out and it has went through a rigorous testing. Recall, actually Chandrayaan 3 landing system, last some 6 to 24 experiments were done at SHAR before. That is, we put up a simulating a moon surface and from 100 meters down, how do we land for different aspects. All the algorithm is called hot test. Integrated hot test was conducted at SHAR.
So we made a moon-like surface here?
At SHAR. And we tested the propulsion system. And we took care of the gravity mismatch between moon and this one.
Correct.
So the counter mass balancing all was carried out. And we did the different propulsion experiment.
And how many times you did that, sir?
Many times, 6 to 7. We have to achieve some 6 to 7 algorithms and understand 6 important tests. But there are many sub-tests. So these are all being done. Make sure that all the sensors, which the feedback system, then the response system, the propulsion response system, how it works, so that we achieved the way in which it has to move.
Correct.
This all was simulated now. Earlier, this all was done in a somewhat way, but now we understood what are the mistakes that happen. In whichever redundancy comes, you have to hover. Yes, okay, if I am not sure whether we can hover, for at least sometimes, take stock and do it.
Correct.
Like our human being, no?
Yeah.
When I come, tech stock,
Take,
some
yeah.
of that sensor. So how to keep the sensors, how is the feedback system. These are all worked out. So URSC is the lead center, which has already done all these things in at Bangalore, integrated cold test. Now we are doing integrated hot test.
Okay.
And SHAR is the best place to do it because even anything happens goes for 10 to 15 kilometers, nobody is there. So nothing to worry about that.
Okay.
So this was tested. So now we are so confident about the landing capability and system. Now we have to reach it. What is important is starting from Earth, going to the moon, and there is a path, no?
Correct, yes.
That path should be, if you start in the precise path, that's the most important aspect.
Yes.
So our worry is launch vehicle LVM3, what we are doing M4, all the parts are made. We make sure that everything is in precision. And the algorithm to put the Chandrayaan 3 along the Chandrayaan 3 propulsion module as well as the lander with the rover all put out together is put in the correct path without any deviation and the best giving maximum energy to it so that it is already in the correct path so that it has a lot of fuel left with it. So we are able to put in a precise path. So on July 14th when we launched in the precise time, it went in the correct path, no deviations.
Yeah.
So that itself gave the argument well that now we have put the Chandrayaan 3 in the desired path, the correct path. So that is almost, we can call it a 60% we are in the right path. Now Chandrayaan 3 is already tested for all these aspects. We repeated all those, we reached the moon. So August 23rd, when we discussed all the maneuvers, we discussed as expected, as planned. With that we went and we are able to launch. At that time, the confidence level was very high in August 23rd at Bangalore. So you are calling the launch time. The ascent phase was done at July 14th here. So we are actually quite confident because vehicle is well proven. LVM3 was well proven with 6 launches already.
Absolutely.
So the Chandrayaan 3 launch had no issues and everything worked perfect. Chandrayaan 3 also was ejected, put in the orbit, desired orbit. From there, ISRO took over, Bangalore took over, URSC putting the satellite in the right path. So that is it. It is a feeling of elation that we are able to capable to do a good job.
Yes, sir.
I will not say it. And success is in the aspect is everything went in the prime decision making. That is, everything went in the prime path.
Yes.
There is no deviation, backup was called upon.
Correct. Beautiful, sir. Sir, is there any other mission that you want to talk about? Is there a mission that you personally like a lot and was very difficult and you still managed to do that?
Chandrayaan 2, there was a lot of difficulties in the beginning when I took over, personally speaking.
Okay, sir.
I took over in July 1st. And July 15th is the scheduled launch.
Acha.
And actually, on that day, we are not able to do the launch. Because there was a small leak in the vehicle. So satellite is in position. So we have to postpone it by a week. Actually, I was not physically well. I had some issues, running fever at that time.
Okay, sir.
So at that time, what happened is we had immediately called all the people. So my S12 colleagues in CMSC, where I came from, my composite entity, because the parts has to be removed. It's a composite part, fiber and fiber. The then chairman, the present chairman was the director there, asked his permission, and then we took out the parts. Within 3 days, we rectified the failure, and within a week, we launched it.
Okay.
So, and the launch was super successful. There's no issue. That is one aspect. As soon as you took over, there's a challenge. And with president in place, we have to go and tell him launch is not on. So it's also a difficult situation. Honorary president was there, going up. So launch was not able to take place. But we had a dedication of the facilities, and what we did is, that is one aspect and final aspect. The real aspect came is during COVID time.
Okay.
We decided that we should have launches. We can't have without launches. So what we put it is, as you know, in COVID, in the first phase, we have our own island. We are all island. We are away from the bigger hospitals.
Correct.
So people are really, the morale was not that good. So we had to take care of the morale and the capability work. And at the same time keep the distance, safe distance between people. Here we are all supposed to work together and do this.
Absolutely.
So we envisaged a plan, a bubble, bio bubble, how to
Correct.
create a bio bubble.
Yeah.
So we made use of all the technologies.
Uh,
So all the datas, we decided who are all supposed to come to SHAR
uh,
and who can be avoided or sitting in different centers, they can give the decision making.
Correct.
So we said, if you have to see a doctor, if you have to see a vehicle, decision making without seeing a vehicle is possible. Those people need not come. Those who have to really be on the side of the vehicle
Correct.
and do some work, those people alone has to come.
Okay.
But how to give the decision making? Real time. So we communicated with the photography, we established the cameras as well as the two-way communication systems.
Correct.
In a very secured system. We established this called Virtual Launch Control Center was put in Vikram Sarabhai Space in Trivandrum.
Okay.
And those experts can sit in their place in designated areas in different centers. And they will sit there and communicate.
Correct.
Different. Thereby we reduced by from 300 people to just bare minimum 100 people.
That's it.
Just 100 people only came here to do the launch assembly, PSLV. So during that time, October, we had a launch in a bubble system. The foods, everything, sanitation system, all will be in their place, individual rooms. Food will reach to them in a sanitized food will come to each one of them so that they don't have to mingle with anybody to eat. And we, in SHAR also, we had a bubble system. Within 15 days, everybody was checked and scrutinized.
Okay.
So we had 2 launches during the peak COVID time.
Okay.
Without any hindrance. And we made sure that the traveling people also are isolated for 2 days.
Okay.
Then we checked them, and we are the government was sanctioned that SHAR hospital is the one hospital before anybody else. They gave the sanction to test all the people.
Okay.
Because it's an important place, so it COVID testing was established here, and our hospital was given the cleared by IMA and people. So that way we are able to do all the checkings,
Correct.
COVID screening and all those things, and took care of the medicine, everything was made available and kept ready.
Okay, sir.
So it went in a flawless manner. I will tell you personally that as the director of this center, showcasing when we are not able to move forward and this one work is not happening, to keep the morale going and to give confidence that in spite of all these things, we can have launches.
Correct.
We had 2 launches.
Yes, sir. That's
So
wonderful.
that is the one, personally speaking, during COVID, that we can put a system in place,
Correct.
overcome all this pandemic situation.
So the place did not stop when the world
World
stopped.
stopped.
That's
And we launched it.
correct, sir.
Satellites came from URC.
Yeah.
People came
Yeah.
in a designated identified vehicles,
Correct.
taken care. Their confidence level was kept in place.
Correct.
Food was given. The best food possible was given.
Yeah.
And people enjoyed it. And also the people all returned back without any.
That's amazing.
So they felt very confident.
Yes, sir. Sir, one thing that we are very excited about and we've been hearing for a very long time is that are we going to put a man in space, sir? And what are the preparations and how do you prepare here for that?
Yeah.
Is that different from the normal launch?
Obviously, the
Yeah.
4th dimension, you see, now we have human being comes into the equation.
Yeah.
The entire things, the ball game changes
Changes.
drastically.
Yeah.
No more it's a payload.
Yeah.
Now it's a live person.
Absolutely.
So obviously, like aircraft, we have to improve the showcase the reliability aspects.
Correct.
At any instant, vehicle is reliable. So you have to first decide on a vehicle. So we are now decided on LVM3 vehicle as
Okay.
the vehicle to take the human capsule to space and bring it back.
Okay.
So the ascent path of LVM vehicle is taken, is now decided. Now what we did, we human certifying the vehicle, human rating the launch vehicle has to be human rated.
Okay.
This vehicle is capable and reliable to take a human to the space. This is one aspect. So we call it the LVM3 is called as HRLV, human rated launch vehicle.
Okay.
So that's a huge activities. You have to see which are the pressure points, flux points. We call it as weak points or the minimum margin time.
Okay.
How do you strengthen this? So and backups.
Okay.
So solid motors has been made carefully. We have tested so many times. More than 20 motor cases has been tested. Some 14 of them in flight and 4 of them in ground.
Okay.
All the parameters checked and we have established the margin. And it's available. Second aspect is the liquid stages. In IPRC, they test the assembly features, the checking points, inspection points, all this mean import. That also import. And cryogenic stage also done the same. Now this launch crew module and crew service module, it's a new thing. It is having a capsule where we can house 3 Gaganyatris. We don't call astronauts, we name it Gaganyatris because it's our going around the space. How to keep them in space, what kind of seat they have to keep, what are the avionics systems, the ECLS, environmentally controlled life support system. We take it for granted, oxygen is available, food is available, everything. How do you making oxygen available, removal of carbon dioxide, that system, the humidity has to be correct. You should be at 45. You can't go to a low humidity, then also water will come out. So this kind of systems, how to put in place. Then comes the shielding the crew module for small debris that comes in place.
Correct.
Shielding. Then the cabin has to be pressurized. Like earlier payloads, it can simply go and come. You need not have pressure. Now without pressure, you cannot survive.
Absolutely.
Because you are used to 1 atmosphere pressure.
Correct.
When you go to space, there is no pressure. So that it should be hermetically sealed. I won't say hermetically sealed inner cabin should be at some required atmospheric pressure. Then outer structure. Then a servicing module which takes care of the keeping the temperature in time, because temperature will get heated up. So you have to maintain a temperature, room temperature. You have to provide oxygen. So service module which is developed at URC. The crew module will be developed at VSSC. This has to be assembled. Now, during the launch of entire mission, at any point, some anomaly happens. You have to take the crew to a safety.
Out of the...
So that you should have a crew escape system in place. That crew escape system, since it's a solid motor of this, we should have a highly accelerating capable crew escape system.
Correct.
So we have 3 motors. One is called a low altitude motor, solid motor, and high altitude 4 small motors. Then we have a crew jettisoning motor. Okay. That is called CJM. That always has to work. That is another one motor which will take all the systems out of the path once the vehicle reaches outer space. Correct. Then we have pitch motors. All these are tested 3 to 4 times with a high acceleration happening. And recently also we have finished. So all those testings, around 25 tests were done. Now that has to be assembled, and we did even first, you would have seen. Now, for different stages, we will identify the locations where it is very difficult to bring the humans to safety. We have to identify the critical points in the launch, in the envisaged mission. So those 3-4 places are there, different altitudes, where it is, something happens, you have to prove that we can bring the capsule safely to the Earth. So recently, 3 months back, we have done a TVD1, technology vehicle. For that, you can't have one full vehicle. It's a very costly affair. Yes, absolutely. So we have worked out only one stage you took. We put the crew module and service abridged version. Then we assembled the crew escape system, went up to 7 km altitude. At that time, the vehicle stops. The crew escape system will eject. Will take the crew module out of that path. This will continue to go in a path. That it has to go away 2 kilometers away from that path within 2 seconds. Within 2 seconds? Yeah, we have to move fast because there is an anomaly happening. Correct. So this has to be taken out. Then the crew escape system taken out, it has to separate from the crew module. The crew module has to come down, and the parachutes has to deploy and safely come in the ocean. And we have to go and recover them. This is also an important aspect. Just there in the middle of the ocean and nobody goes and recovers them also is a dangerous aspect. So the communication system has to be, without any mistake, the communication system has to happen. You can't afford to have no communication. Correct. Because there is a human inside. Correct. We are all, this first test is over. Then we'll have during service in vehicle also some anomaly can happen. At that time, you have to abort from the pad itself. So that test we are now planning. One test is over. We are planning one more. Okay. 1 or 2. Then different altitudes, 7 kilometers, 17 kilometers. So different altitudes are there. Going to space also, whether any anomaly comes, how we will bring. So all these aspects, test is being done. While we are doing all these tests, the ECLSS and support system, the preparation, because we are putting a crew inside. Here, the crew has to be trained. Correct. And then we have to see the ECLS support system and all the aspects, how well it will go together. In between, as we go, we should have called the IVHM, Integrated Vehicle Health Monitoring System. that should be able to identify if an anomaly happens, the parameters which gives indication that that is going to happen, an anomaly is going to happen. That also you have to predict.
You
It
have
is
to
like
predict that.
I am not feeling well. Some parameters you know, no?
Yes.
Even though if you check, nothing is seen.
Yeah.
But you have an indicators.
Correct.
Like that, you should identify the indicators and look at those parameters closely. That is at least 2 seconds before an actual anomaly happens. You should be able to predict that anomaly happens,
Correct.
and the decision to be taken to take the system to.
Yeah.
It can be time. It's well also people doesn't exist. So this has to be fine-tuned and looked at it.
Correct.
So we have to put a lot of redundant system. We have a primary and backup usually. Now we have quadruple.
Correct.
At any time we have the safety. TMR, logic, all those for the ground system. While PL is being loaded also, we have to be very careful. So all these aspects, we are doing a test. We are trying to, and in all this course, by this year end or beginning, we should have the G1 to be capable of launching.
And by the end of this year or next year, we'll be able to launch?
First G1 without anybody, human being.
Okay.
We want to go through a nominal launch and bring back the crew module back to Earth. This is as if nothing happened.
Without the human?
Without human. Because we have to do at least 2 launches without any change has to be done.
Okay.
Then only we will put the humans. Gaganyatris.
So approximately we will take around 2 to 3 years?
Next year end we are to targeting to do all this. Figure we are going on doing test. There will be a lot of inputs coming on.
Correct.
We have to update all these things. But we have to start doing. So we are making the vehicles ready, 2-3 vehicles ready, the Gagan, the crew modules.
And the Gaganyatris have been identified?
Yeah, identified. No?
And they are not in public, right? They are not in public.
Yeah, it is announced in public.
It's announced in public. Okay, great, sir. So you were mentioning about some weather challenges during the Chandrayaan 1 mission, sir. What was that?
Yeah, what at the time I mean a young engineer there at the time. I think year 2008, when the Chandrayaan 1 is getting assembled and the launch vehicle, there was a small RFDS leak. So that has to be corrected, and there was a doubt about some inclement weather. So it was well checked and go on checking, make sure that all the aspects are taken care. Then we are able to do this. What I am just trying to point out is the inclement weather will play games with you. So we have to be very clear what is the go, no go situations. There is no such called there any variations. So that was well established. So that gave us a lot of confidence in whether what kind of things we will clear or we will not go or not go for a launch. So that gave a lot of confidence in understanding the situations for all the people who are involved. So that makes the team more robust. So, look for all the other aspects. That is one. Then there are some inclement weather during the LUM3 development time, like we called mock-up. Before doing in launch, any development vehicle that is called a mock-up. So there was an imminent Varda cyclone. So we brought the mock-up vehicle to the launch pad, did all the tests, and there was a time Varda is going to cross the land. So before that, we have to bring back it safety to the launch assembly bay. So we do that. So that also we have carried out. Then during the 2019 November times also we had one vehicle was identified. The time was short. We have to have a launch. So suddenly the charge around the Sriharikota seems to be higher than the threshold levels. So we have to really take a call. We kept quiet. We postponed by 10 minutes. We looked at it, and then it dissipated to a lower level, which is became benign. And then we gave the clearance with all the range. So the confidence on the range systems was very high, and it gave the clearance, and we launched it. So that also gave, yes, we are able to take a decision based on the system that we have put in place, based on knowledge that we have acquired. We call it as lesson learned. So we never lose the lesson learned. So that also gives you a lesson. How do we able to make the decision is, we have past experience of all these critical areas of launches, take them into consideration, what was the decision taken, and what happened, why. Now, we have to look at the reliability of the data that we are getting. It's correct. So decision was taken by delaying it and then go ahead to launch. So this augurs well for the team as well as to the system.
Sir, is ISRO collaborating with other global organizations, and if yes, in what missions and in what capacity, sir?
Yeah, there was a lot of collaboration. Even during earlier days, we used to get launches, vehicles. Nikki Apache came from USA and some from Russia. We launched sounding rockets.
Correct.
Then during the PSLE for the liquid stages, we worked with the ESA. We put our efforts in developing a vehicle. The configuration that's called our second engine, liquid engine. The cryo stage, we got it through Russia. Then we ourselves developed. They gave some stages and we had some GSLV. After that, we ourselves developed our own cryo stage. Now, beyond that, we went to from 10 stage. First, we went to 25, C25. Now we are going to C32 for the human missions. So we have developed our own cryo technology. As we developed collaborating with launch vehicle and developed the vehicle, we at the spacecraft and this one, initially with Aryabhatta and remote sensing, using the help of Russia, we launched many other remote sensing satellite. Something developed by them, then developed by us. Then, as the PSLV got ready, we had our own remote sensing satellite and launched it in our own launch vehicle. At the same time, we had given a thrust on the communication satellite. The INSAT 1 was actually realized from USA through Ford Aerospace, and we developed that satellite system, some 4 or 5 satellites. Then we developed our own INSAT 2 indigenous satellite development. We started our own, and we started launching in our own launch vehicle like GSLV and LVM3 vehicle. So what happens is, some of the satellites also being used using Ariane in Gaganyaan, not Gaganyaan, at French Guyana using Ariane vehicle. We launched many of our communication satellites. So that way, it is a commercial terms. And then some of the satellites of like Brazilian Amazon satellite was launched by us in 2021 by our PSLV C51 exclusively. So, like many countries satellites, Singapore, Israel, so many countries satellites also we have launched. At the same time, now from asking help from others and working with them, developing the technology so that we also get the technology like liquid engines. Then we started collaborating. Then we started complementing. Like we made the satellite for 2 of the satellite, like HILAS and WTM satellite with ESA. We made the bus and the payload is with them. We made satellites which was commercially launched. This is one way of knowing that what is our strength and what is their strength. They want to use it for their requirement, not our requirement. Then now we have come to the level of NISA, where there are 2 payloads. One payload is from India and the other payload is from JPL, USA. So they are putting one of the costliest satellite to cater the regions where we want to monitor the latest predictions like weather and all the aspects.
Correct.
So that means we are collaborating and complementing each other.
Correct.
It is each one's strength. So in Chandrayaan 2, Chandrayaan 1 also some payloads, many payloads were imported or this one and done. Now Chandrayaan 2, Chandrayaan, we have our own payload because our own scientific community and astronauts, academicians want to do their own development. So a lot of payloads are developed in the Institute of Astrophysics, many people. So we have put that in our Chandrayaan 2. So the collaboration and complementing will happen so that the mutual helping each other, so that each one plays to strength.
Correct.
So that it augurs well, both economically as well as for a better outcome of the scientific mission. So this helps you in doing. So it's always better to have an agreement and collaborations with many countries. I think today ISRO, as part of the government of India and representing government of India, we have I think around 200 agreements internationally with many countries in many areas.
That's brilliant, sir.
That's how it goes up.
Sir, a lot of startups have now started to come into picture. So, sir, how are they looking forward to the space exploration and what is the future of space exploration and ISRO? How does it all look, sir?
So far, ISRO was pioneering all the space activities, technology development activities as part of the government. A time has come where government is looking at it. How do we increase this contribution to the station. So actually, government rightly under our beloved Prime Minister Modi sir, as put up in a space policy, encouraging the entrepreneurs and the private players, the startups and the industries to take part in not only in launch vehicles, also spacecraft and application, all aspects. So a very comprehensive space policy is brought up. And in space, one group team, one in space agency was created under DOS, Department of Space, which will look at enabling all these players, stakeholders, to make use of the facilities that is available not only in ISRO, wherever it is, and create a facility, encourage them, handhold them with experts, those with retired, all those people. Enable them how to go about and how to encourage them. So when there are people now who are some startups are available who are trying to do in launch vehicles and spacecraft and applications. So we are providing a platform and policy which enables them to go about their work and do launch. So recently, Skyroot, and there are two startups where their suborbital vehicle launch was located. So at Sriharikota and Vikram Sarabhai and many centers, we have helped them in developing their stages and this one. They are done on their own. Some control systems and distribution systems was provided by VSSA and this one, and the assembly was done at SDSC SHAR, Sriharikota. We handheld them in going ahead with the how to assemble and do this, and we provided the full range support startup, and we had a successful suborbital launch of Skyroot Vikram S, and recently this year Agnibawn sorted a suborbital controlled flight by Agnikul, which is based at IIT Madras. So this is launch vehicle. That's what we as SHAR, we have helped them to take care of and do this. So it's a hand-holding method. Now we are also trying to develop, we have one of the best solid matter realizing facility in Sriharikota, which can do many things. So such a facility is not available to them. So we are hand-holding them, and we are making stage some solid matter preparations and this one for based on a procedure, we work out what is the cost involved in making and helping. So they come with a requirement, we see what can be done, and we make them and give it to them, including testing also may happen at SHAR, static test. That each stage when it's made, it has to be tested and seen what its performance. Based on that only it can be put in actual use. So the private players, then we call non-government entities. That's one aspect. So that they are now trying to develop their own vehicle, and we are hand-holding them and trying to develop, including assembly of the vehicle and launch. That's one aspect. Second, another aspect is we are also now trying to we have developed our own PSLV, GSLV, LVM3, and SSLV, small satellite launch vehicle. Each one has a capability. PSLV has a 1000 to 1500 kg capability. 2300 to 2500 kg capability is a GEO. GSLV, around 4 to 5 tons capability is now available for LVM3 for GEO. SSLV can launch 500 in their 400 kilometer orbit. Now, PSLV, we are trying to outsourcing, and industrial consortium has taken over, and they are planning to make 5 PSLV on their own. Some help. We will be providing all the help so that we are enabling an industry to do this on their own. And the payload has to be put and we launch. That is, work is going in full swing. We are trying to put first industrial consortium realist PSLV vehicle at the earliest by launch. Second aspect is we are now trying to do a technology transfer of SSLV also to any industry which is coming forward. So InSpace is doing the shortlisting of the industries, which is the nodal agencies for all these players of technology transfer for this. So we from SHAR and other launch vehicle related centers are trying to give them all the support to see how this SSLV technology transfer can happen. This is also one of the. So this augurs well that many industries will take over the realization development. So future is they will develop and their own will just start configuring a vehicle. So we are trying to increase the ecosystem with more participants, so that the revenue, which is today stands at 8 billion, goes to 44 billion from Indian side. And so government has come up with a very good, robust space policy, so that we can make use of all this policy available. So the many players are now coming.
Yeah.
That you would have now seeing there's a real enthusiasm in many players. While doing this, there are small players with some small payloads in the satellite application, spacecraft application.
Yeah.
If they want to make a spacecraft and then launch it in a launch vehicle and put it in space and do it, it's a very costly affair.
Absolutely.
So we have a platform called POEM, payload orbital platform. That is the last stage of the PSLV, the fourth stage, the PS4. We are converted after its primary function. We are modifying and converting into a platform for a 6-month capability.
Correct.
It can go around Earth at around 300-400 kilometer altitude for 3 to 4 months. Useful life. We are trying to provide a power. We call it payload experiment module. There, people can put a 5 kg, 10 kg payloads at a nominal cost and put there in that and do the experiment.
Correct.
And clarify whether the payload is working in space, how it is. Once, based on the feedback, they can modify and improve that payload and make a full-fledged satellite. So they are, without knowing, they are not spending more money. They are actually putting, it's a cost-effective solution that we are providing.
Correct.
This is actually a societal application that many players will have many ideas. Even we have our own systems, small developments we have made. Instead of doing a launch vehicle and spacecraft for this, we are trying using a spent stage before bringing it back to the Earth and destroying it.
Correct.
We are doing this experiment, ensuring that, like hydrogen fuel cells or so many things, space. How to do it experiment in space? It's not easy.
Yes.
So this is a very frugal method of doing experiment in space with a minimum funds.
Correct.
This actually enables many players to come forward and do it. And we are making many players are even more than 10 to 12 people have done their experiments.
Wow. Now, what I want to ask you is that, sir, now we are going to put man in space. After that, are there any plans of putting man on moon?
Yes, as you know, once we are now working on the beginning, we should have a long-term plan.
Correct.
So, Prime Minister Modi himself has taken a comprehensive review of how to go about improve this system. So now ISRO is interested with the development of technologies, research, like going to interplanetary, look at the interplanetary systems and improvement of technologies, which can be used by many players. So in this regard, once the Gaganyaan program, when the phase is coming, we are trying to put in place. Just sending a person, a human being to space and bringing back, we have proven technology.
Correct.
But you should have some useful. So we, what we are told in this age, there was an idea given, one space station of India should be put in place.
Okay.
So we have a Bharatiya Antriksh Station.
Okay.
And Bharatiya Antriksh Space Station. That's a BSS. Bharatiya Space Station, we call it as. So we are trying to put in separate modules using our LVM-3 vehicle and some new vehicle which we have to develop called NGLB, called Surya, vehicle called Surya. We are just put it in the drawing board. We are giving the proposal to the government. Using this, we will put the modules in space. Modules in space when you are trying to put and assemble in space. So this will give a platform for our Gaganyatris to go to that space station and do some useful experiments, which is important aspect.
Correct.
So that is one aspect of future development. For this, we require our LVM-3 vehicle and sometimes we require a new vehicle with a higher capability, 10 capability vehicles. So we have put, as I told, we have one vehicle called Surya vehicle with a new LOX methane engine, we call it. It's a good, developments are going on. As we do this Bharatiya Antriksh Space Station developed and the modules are developed, we use that experiment. The follow-on to Chandrayaan 3, out whether we can send some spacecraft, take some samples and bring it back to Earth.
To Earth?
Yes,
okay.
To our place, so that we can study ours. So we are developing a study. You have to understand, we are importing, we are doing, that's called follow-on called Chandrayaan 4, 5. And it can have collaboration with the like-minded countries in space exploration, further studying, then the Mars, Venus studying. In addition to this, by 2040, we should out to see to land our Indian on moon and bring him back to bring him or the Gaganyatri back to Earth. So towards this, we have a very good super heavy lift-off vehicle of Surya H. We are working on that vehicle so that up to 25 ton, 30 ton capability is there. So we have to put a module, take it to moon, land, then come back.
Going to moon is easier than coming back from moon?
Going to moon is one aspect which you have proven. Actually coming back, you have to reverse the aspect. I will put it in simple mathematics. We are importing a module, an energy of around 8 to 9 kilometers per second.
Correct.
Then it's going towards the moon. After going to the moon, the moon's gravity will work it out and pull it. We have mastered that. I'll say we are well tuned to that technology.
Correct.
Then reduce the speed and land on moon with zero velocity, right? So you are imported and then reduced. Now again you have to lift off from that place. You don't have a launch pad or anything. So in that place you have to lift off, go around moon, then again come towards Earth. You will achieve some velocity, not that much velocity. Now you have to break it gradually because you are now going to enter a dense atmosphere, a natural protective atmosphere of the Earth.
Correct.
You have to going through the atmosphere is not easy. You will burn up. If you are not, one slightest mistake, entire thing will get broken to pieces. So you have to enter through this, gradually breaking, then go through the atmosphere, and then come back to Earth in designated place.
And then
you have to kill the velocity to zero and land. Throughout, human being has to be safe.
Correct.
And we have to bring something, and some useful has happened. Simple mathematics,
correct.
right?
Yes, sir.
0 to 9 kilometers per second. Then kill that velocity,
correct.
again provide velocity,
correct.
come back to Earth, and at all the same time,
make it zero again.
Earth is going around the sun, moon is going around Earth, all those aspects are happening. So orbital mechanics, these are all calculations. So mathematics. So this is what we have to do. This is what we have to do, and we have to bring in the capsule form, the Gaganyatris back to Earth. So technologies has to be developed.
Correct.
And a heavy lift vehicle also is here. So for this we require require a third launch pad because a separate launch system to take care of this new system. All are new fuels and new system. So that has to be catered, and we should have a reliable system to bring it, do it regularly. So these are the technologies that has to be developed. Infrastructure has to be developed here. So then we are working on a reusable launch vehicle. You would have seen we are done at Chitradurga in Karnataka. 2-3 experiments we have done to bringing back a. It will go vertically land, then land like a plane. So that we experiment last mile how to bring such a reusable launch vehicle back to Earth, back to airport. So we are planning to have one airstrip. And a jetty, because huge systems, now as the systems become bigger, you cannot bring it through road and all. So we should have a boat jetty.
Correct.
As the Gaganyaan, that is one, but that is not the primary reason. Primary reason is when the Gaganyaan vehicle assembled and when you move out, when you are launched, anything, immediately any anomaly happens, that crew module will be taken out of this and pad abort will happen and fall some 3 kilometers, 4 kilometers away from this place. If you want to recover them, ships has to go from Chennai or Visakhapatnam and reach that place, and immediately from boat jetty we can go.
Correct.
We can recover very fast because you have to look at the mindset and all the other aspects. So that way also, this boat jetty will help in catering to all the requirements. So we are trying to develop an infrastructure to cater to all aspects of transportation system, the recovery system, and the infrastructure in place. So this will help you making. So our idea as a plan, we have follow-on missions of the Chandrayaan, putting a space station, Bharati Under Space Station by 2035, and then by 2040, with all the technology developed, with a vehicle developed, we can try to put an Indian, a Gaganyatri on moon, and then bring the Gaganyatri back to Earth.
Sir, what an incredible podcast. There was so much to learn about ISRO, Satish Dhawan. Space Center and about you also, sir. I mean, I cannot express in words how amazing it was to know about the missions, the Space Center, and everything. Thank you so much, sir, for taking out the time. Thank you so much for sharing your experiences with us. And from JK Super Podcast, we would like you to thank you for the service that you're giving to the nation, sir. Thank you so much, sir.
Thank you.
Thank
Jai
you.
Hind.
Jai Hind, sir.